Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question. Question number 23 of NEET Physics paper 2014. Students, let us solve the next question number 23 here. Two thin dielectric slabs of dielectric constants K1 and K2. This is a parallel plate capacitor. In between two slabs are given, inserted with the dielectric constants K1 and K2, where K1 is less than K2 are inserted between the plates of parallel plate capacitor as shown in figure. The variations of electric field E between the plates with distance d. Which distance is d? Actually this distance is d. From here to here, one plate to another plate. This is what is the distance. This distance is d. As measured from the plate P is correctly known by. So basically the question is that you have two parallel plates. So this is called a parallel plate capacitor. Now this is P and this is Q. This plate is always positive and this plate is always negative. Charges are only inserted or present inside surfaces or in the interior surfaces. The charge over there is 0 and 0. Only electric field is established from this face to this face. There is no electric field outside. So in this situation, if nothing is present, then this is the electric field E, and this is the distance d, which is just a constant. So if I talk about only E and D variations for air capacitor, it is a constant. Only this is a constant because E equals to sigma over epsilon naught K, where K is 1 for air. So therefore sigma upon epsilon naught, and sigma is Q over A epsilon naught. So everything is constant here. So therefore this is just the constant. From here within the plates of the capacitor, the electric field is always a constant. But the situation is that we have inserted two slabs of different dielectrics. So in this situation, the electric field will not be a constant from this end to this end of the plate, or as you move from point P to the point Q, because of the presence of the K. Now, as I told you here, the E formula is sigma over epsilon naught K. So for we have three situations actually. First is air. When air is there, what happens? And K1, K2 there, what will happen? Now, when this is air, the formula becomes sigma upon epsilon naught. When this is K1 filled with K1, the formula is sigma upon epsilon naught K1. When it is filled with K2, for this K2, this is sigma over epsilon naught K2. So this is how the electric field is changing. Here this number, this is 1 here, this number is less than, given K1 is less than K2, and this air 1 is less than always K1. Any medium is having a dielectric constant more than that of air. So air K for air is also less than this. So this is the order of K. As you can see from these relations of E and K, sigma and epsilon are same for these situations. Only variations is E over K, and E is inversely proportional to K. If E varies inversely with K, the one having less K has more E. The least K is for air, so, and then this one, so for energy this is the most. Electric field is the most electric field here. So the electric field is greatest here, and then here, then here. So this the arrangement, the order is just reverse. That is E for air is greater than E for K1 dielectric and E for K2 dielectric. So, but whatever is that particular part of this is the capacitor, and I have this portion filled with K1, say, then within that space of K1 the dielectric, the electric field is constant. Within this space is constant, so as long as this K1 continues, the value of electric field is same. Similarly, for another portion of K2, the electric field is same in between. So therefore, it maintains a constant value as soon as it finds a dielectric, or even it is air. So therefore, I can write that for this one is having, if I draw the graph, then for E versus D, as I start from air is being the greatest one, and it moves up to whatever distance it is, the gap is there, it is there. So this is for air capacitor. Then I find a dielectric K1, as you can see here in the see the situation is, let me draw this first. This is filled with one dielectric and another dielectric here. This having K1, this is having K2. So, and that is very thin also. That's given very thin dielectrics. Okay, so then I find K1 as I move from here to here. I'm moving from P to Q. So this dielectric, the E will drop down because of reciprocal value. This will drop down. So if it is something like this here, something like this there, then something like this will be less than that. This way it will vary, and we have also from here to here is air, and then again drops down, then air, then drops down, then air. So this way it will vary. So from here to when it finds another one, it will be, this is for K1, this is for K1 dielectric, and then again I have air, so again it will rise up to this level, air, and it will continue. It will continue till there is dielectric K2. When it finds K2, then it will decrease them or lower, it will lower than the K1 because this one is having less electric field than the earlier one here because of greater value of K2. So this will be below this. So this is like this somewhere here, K2. This is for K2, and after I leave this point and move towards this plate, then the air starts coming in, and when air comes, then again it attains this value. So this is how, this is the arrangement, and here you reach the point, this plate Q. I start from plate P and I reach the plate Q. I find first air, then K1, then air, then K2, then air. So this is what is the situation is, and this situation is best described by, you can see that this is not possible because K2 electric field is more than this. This is not possible. Here I can see that this K2 is more than, this is not possible. Here this one is correct answer. This is not possible that all the inside everywhere the electric field is constant. This is the right answer because you can match this one with this one. You can see here starting with E we have got 3 lines, 1, 2, 3, and in between we have 1 2 values like that, because this is how it is done. Okay, so this is the answer to this question. Thank you very much.